In this lesson, we're continuing our path towards investigating how a firm would optimize behavior, in other words, maximize profits in a world where the firm knew its costs and it was given some exogenous price, some signal as to price. Taking that price and its cost, how does it maximize profits? And since we're talking a lot about profits, in this particular video, what I want to do is think about how would you actually show profits on our graph. So let's recall the type of graph that we've been dealing with here. We'll draw our axis system, and we have on the vertical axis dollars and cents, and on the horizontal axis we have quantity. And we know that profit maximization requires a very simple rule, and that is you want to set marginal revenue equal to marginal cost. And in our particular instance that we're dealing with here, where the price is parametric to the firm, it's fixed, then marginal revenue is going to just be equal to whatever that price is. We call that P0, and so we'll call this MR0. It's a horizontal line. Any output level you choose, every extra one, you get exactly that price. So suppose it's $3 a unit. If you produce 100, you get $3 for the 100th unit. 101, you get $3 for the 101st unit. That's why it's shaped like this. And then we wanted to put marginal cost in there, and we understood marginal cost was really U-shaped, but we also knew that while it's U-shaped, the downward sloping side is kind of a red herring. It's not where we want to go, okay? The marginal cost curve on the upward sloping side is where the firm is going to maximize profits, and that point occurs where marginal revenue equals marginal cost, and we'll call this point, for now, Q star. And so the question is, given this situation, can I depict profits? That is, total revenue minus total cost. Well, I actually have a term for total revenue already. I can see that. I can see that on this graph because I know total revenue is equal to price, which is P0, times quantity, Q star. Well, if I were to go ahead and take, let's say, price, that's this vertical height, times quantity, that's this horizontal distance. Well, if you remember, multiplying base times height will give you the area of that rectangle. And so the area of this rectangle would be total revenue. Now, how about total cost? Well, we wonder about this. Do we have anything on this picture that's going to help us out? And you might be thinking, well, you know what? I know marginal cost is the cost of extra unit. Each extra unit is depicted by the marginal cost. So if I were to do that old calculus trick of integrating the area under that curve, in other words, if I would just go about my business of perhaps adding up every one of these vertical bars underneath it for each output level, how much was the extra cost associated with that, maybe that's a proxy for total cost. Turns out that's a trick. It doesn't really work because, as we know, marginal cost has absolutely no information about fixed cost in it. Fixed cost and marginal cost are like apples and oranges. They just don't get together. And so in this case, all I could get by adding up all those areas under the marginal cost curve would be the variable cost, but nothing on fixed cost. So I got a problem. I need something else. And that something else is not going to be too hard to get, because what I'm going to do is bring back one of those little bubbles that comes up over the cartoon character's head, gets this brilliant flash and says, you know what? I recall that we defined average total cost as equal to total cost over output. So if I were to go ahead and multiply both sides by Q, I'd get Q times average total cost would be equal to total cost. So now I see that if you just show me the average total cost curve, I can actually figure out in that graph what it's going to look like. So let's draw another graph. We'll again put the marginal revenue on this graph, and we'll put marginal cost, but I'm just not even going to show you that downward sloping side. Even before I had it as a dashed line, because we know it's there, but it's not relevant to the firm, so why clutter the graph? We'll call this MC. And now I remember from what we just did that profit is equal to total revenue minus total cost. But that's the same thing as saying profit is equal to price times quantity minus average total cost times quantity. We just did that in that little recall bubble there, we've discovered that total cost is just the same as quantity times average cost. That means I can rewrite this as saying profit is equal to quantity times, I'll just pull quantity out, the bracketed term, price minus average total cost. And that's good, because what that tells us now is that profit is just written as the number of units you produce times the per unit markup. Price minus average cost is the per unit markup. This is quantity times per unit markup. You're going to have profits. Well, I need an average cost curve. What's my average cost curve look like? Well, we remember the average cost curve is U-shaped, and we remember that it has its minimum on the marginal cost curve. So that's going to look something like this. That would be a typical average total cost curve. How did I know it was there? I don't. I have the pen. I drew it there. As long as it meets the conditions that it's U-shaped and its minimum lies on the marginal cost curve, we're good. I put it there. Now we can go ahead and find out what happens for profits. In this particular situation, we have Q star, where marginal revenue equals marginal cost. And at that Q star, I know this distance is equal to price minus average total cost. And this horizontal measure is equal to Q star. And once again, when you take base times height, you have the area of that defined rectangle. So the area of this defined rectangle would be profit. So it's important that we know this, because the size of profit is going to drive a lot of our results. Right now, the sign of that profit is positive. We're going to have situations where the sign is actually negative. That's going to make life not too friendly for the firm, but we're going to walk our way through that too, because that's part of what being in an economic world is all about. But I want to draw this picture one more time and talk you through it, and just to make sure you understand exactly how this thing breaks out. So we'll draw a similar picture, and I'll go a little bit faster this time. And now I can think about the various areas there. So let's start by saying I'm going to show you that this area, price times quantity, will define the area of this rectangle. So what we'll say is that the yellow shaded rectangle is total revenue. And now, what's total cost? Well, we remember total cost. Total cost was ATC times Q, right? Output times average total cost will give you total cost. And so I can shade that as this blue shaded rectangle is now our total cost. And of course, what that means is it leaves left over exactly what you shaded in the last slide. This gap is profit. It's the residual of revenue minus cost.